हेलो, वॉइस चेक। नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ इंस्ट्रूमेंटेशन एंड मेजरमेंट्स। कैसे हो सब लोग? आईएन का जो कुछ बच्चे हैं, टोटल इंस्ट्रूमेंटेशन स्टूडेंट्स whoever आर वेटिंग फॉर द कंटेंट, ओके, महा रिवीजन के लिए वेट कर रहे इंस्ट्रूमेंटेशन के गाइडेंस के लिए, उन सब लोगों के लिए आज मैं एक सब्जेक्ट लेके आ गया हूं, दैट इज सेंसर्स एंड इंडस्ट्रियल इंस्ट्रूमेंटेशन। ओके, सो जल्दी से जल्दी ज्वाइन करो बेटा, हम सब लोग स्टार्ट करेंगे। कितने लोग लाइव में हैं एक बार मुझे कंफर्मेशन कर दीजिए बेटा। ऑडियो वीडियो सब कुछ क्लियर है? One of the important core subject for the instrumentation students is a sensors and industrial instrumentation, and जितने लोग double E people are writing the instrumentation paper as option 2, उन बच्चों के लिए भी industrial instrumentation and sensors is one of the core topic. Okay, so जितने लोग लाइव में हैं एक बार मुझे कंफर्मेशन कर दीजिए बेटा। ओके, चलो। So what I am going to discuss today, what are the basic things that I am going to discuss today? एक बार जितने लोग लाइव में हैं, जितने आईएन का स्टूडेंट्स हैं, मुझे एक बार कंफर्मेशन कर दीजिए। और जितने लोग डबल ई का स्टूडेंट्स भी हैं एक बार मुझे कंफर्मेशन कर दीजिए। यस, डबल ई, परफेक्ट। आईएन, नाइस, ओके। My dear students, the subject sensors and industrial instrumentation, actually speaking, आईएन का core subjects में बहुत important subject है। So if you see the core subjects of IN, instrumentation gate subjects, if you see, the gate instrumentation core subjects, so these are the core subjects. The core subjects, if you see, sensors and industrial instrumentation. Okay, next, optical instrumentation. Optical instrumentation. Next, microprocessors and PLC. Okay, so these are the major weightage subjects. So these are first core subject, second subject, and this is a third subject. ओके, प्रोसेस कंट्रोल भी एक सब्जेक्ट है, लेकिन वो बहुत कम वेटेज आ रहा है आजकल, वेरी वेरी लेस वेटेज। ओके, सो जितने लोग इंस्ट्रूमेंटेशन है वो लोग को ये पता होगा ये कोर सब्जेक्ट्स का इंपॉर्टेंस क्या है। सेंसर्स एंड इंडस्ट्रियल इंस्ट्रूमेंटेशन का वेटेज विल बी कमिंग अराउंड 13 मार्क्स, ऑप्टिकल इंस्ट्रूमेंटेशन विल बी कमिंग अराउंड 6 to 8 marks, and this is also around 6 marks. Okay, so this is the major idea that you should maintain. Okay, and in the upcoming years these subjects are going to have a lot of weightage, because industrially most demanding subjects है ये। okay, तो जो लोग research करना चाहते हो, जो लोग PhD करना चाहते हो, so they have to choose certain fields which are emerging। so इसमें sensors है, क्योंकि IoT के लिए sensors का knowledge बहुत important है। क्या सेंसर यूज करना, कैसे इंटरफेस करना डिजिटल सिस्टम को। ओके, तो इनके लिए ये पर्टिकुलर सब्जेक्ट्स बहुत इंपॉर्टेंट है। सो आज मैंने सेंसर्स का सब्जेक्ट स्टार्ट करना चाहता हूँ। सो आज मैंने सेंसर्स का इंट्रोडक्शन, सेंसर्स का आइडियोलॉजी देना चाहता हूँ। सो सेंसर्स एंड इंडस्ट्रियल इंस्ट्रूमेंटेशन, सेंसर्स एंड II, these are majorly II, what we call as II, sensors and II, industrial instrumentation. So majorly it is suitable as called as transducers also. So if you can see that, it is also called as transducers. So if you see here, majorly the syllabus is involved as resistive, sensors and II. So इसमें first topics that is most important is the resistive sensor, capacitive sensors, next inductive sensors, piezoelectric sensors, Hall effect sensors, and their signal conditioning. Signal conditioning. Excellent, Rohan ji. Okay. तो बहुत दिक्कत है आईएन बच्चों के लिए, क्या प्रिपेयर करना, कहाँ से स्टार्ट करना। आजकल इंफॉर्मेशन भी नहीं मिल रहे। तो कैसा हो रहा है आपका प्रिपरेशन? अभी एक हफ्ता, जस्ट 1 week टाइम इज देयर एवरेज। नाइस। So here the signal conditioning plays a major role. सिग्नल कंडीशनिंग बोलते हैं उसके ऑप एम्प का रिलेटेड, एनालॉग का रिलेटेड क्वेश्चंस आने की चांसेस बहुत है. ओके चलो नेक्स्ट, दिस इज अ पार्ट 1. दिस वी कैन टेक इट एज ए पार्ट 1. नेक्स्ट लेट अस टेक द पार्ट 2. पार्ट 2 में क्या आएगा आपको? मेजरमेंट ऑफ डिस्प्लेसमेंट, वेलोसिटी, acceleration. Okay. Next, here measurement of displacement, velocity, acceleration. Next, measurement of temperature, and radiation. See, under the temperature, what we are going to get? Under the temperature we are going to get RTD, thermistor, thermocouple, semiconductor sensor. Next comes the radiation. Under the radiation, what we are going to get? Pyrometers, bolometers. Next, measurement of pressure. Okay, so when I say pressure, here we are having the low pressure, medium pressure, high pressure. Okay, next, measurement of flow rate. So इसमें बहुत सारा है. ओपन चैनल फ्लो मीटर्स, मेजरली आपको मैकेनिकल फ्लो मीटर्स एंड इलेक्ट्रिकल फ्लो मीटर्स. So if you see the mechanical flow meters, again list is big. Mechanical flow meters, you see the mechanical flow meters, and if you see the electrical flow meters, the list is big. तो सिलेबस का ब्लूप्रिंट होना जरूरी है. सिलेबस का ब्लूप्रिंट होना जरूरी है बेटा. अगर आपने नया सब्जेक्ट्स को पढ़ रहे हो, इलेक्ट्रिकल फ्लो मीटर्स, नया सब्जेक्ट्स को पढ़ने के समय आपको डेफिनेटली आपके हाथ में ये सिलेबस का ब्लूप्रिंट होना है. थोड़ा सा इंकरेजमेंट होना चाहिए बेटा. एक्चुअली ये सेशन हमको प्लान्ड नहीं है. ओनली वी आर टेकिंग द इलेक्ट्रिकल एंड ईसी सब्जेक्ट्स एंड कंप्यूटर सब्जेक्ट. बट बच्चों की डिमांड से, बच्चों की रिक्वेस्ट से, मैं खुद से रिक्वेस्ट कर दिया इंस्ट्रूमेंटेशन के लिए। पता है आपको इंस्ट्रूमेंटेशन का सिचुएशन कैसा है? ओके, इंस्ट्रूमेंटेशन का कैसा सिचुएशन? सो अंडर द मैकेनिकल फ्लो मीटर्स विल बी हैविंग वेंचुरी मीटर, will be having the venturi meter, orifice meter, nozzle, rotameter, pitot tube. So these are the mechanical flow meters. Is it clear? Can you tell me what are the electrical flow meters, my dear? इलेक्ट्रिकल फ्लो मीटर्स के बारे में कुछ इंफॉर्मेशन दे सकते हैं? जितने लोग लाइव में हैं मुझे एक बार प्लीज टाइप इलेक्ट्रिकल फ्लो मीटर्स का लिस्ट बताइए। इलेक्ट्रिकल फ्लो मीटर्स वर्टेक्स सरिफाइस, नो भैया, नो नो नो। इलेक्ट्रिकल फ्लो मीटर्स में आपको मिलेगा अल्ट्रासोनिक फ्लो मीटर, इलेक्ट्रोमैग्नेटिक फ्लो मीटर, टर्बाइन फ्लो मीटर। I will write in full form. This is ultrasonic flow meter. Next one is electromagnetic flow meter. Next, turbine flow meter. Next, hot wire anemometer. Okay, so please make a note of all these points. Hot wire anemometer. These are electrical flow meters. अवधेश पाटिल, रोहन, सुमुखा प्रधान। Nobody is there from instrumentation. I think only Rohan. Rohan, being an instrument student, you could not do the mistake. Electrical flow meters. Okay. Chalo. So first I am starting the resistive. So resistive sensors. One of the important thing in the resistive sensors is the strain gauge. So strain gauge converts mechanical strain to electrical strain. Strain gauge converts mechanical strain to electrical. So I will write the important formula here. आई विल राइट एन इंपॉर्टेंट फार्मूला। तो स्ट्रेन गेजेस ये है ना, हमको इलेक्ट्रॉनिक वेइंग गेज में यूज करते हैं। व्हेनेवर आपने स्ट्रेस अप्लाई कर रहे इलेक्ट्रॉनिक का सरफेस के ऊपर, तो द सरफेस गेट स्ट्रेच, इसके बॉटम में आपको एक स्ट्रेन गेज रहता है। सो कितना आपने स्ट्रेस अप्लाई करके उतना अनुसार मैकेनिकल स्ट्रेस की वजह से वो वायर का डायमेंशंस में चेंज होगा। वो वायर का डायमेंशन से चेंज होने की वजह से डेल्टा एल आएगा, डेल्टा एल की वजह से डेल्टा आर भी आएगा। समझ गया आपको? ओके, सो ए मैकेनिकल स्ट्रेन को इलेक्ट्रिकल स्ट्रेन कन्वर्ट करने का डिवाइस को हम बोलते हैं स्ट्रेन गेज बोलते हैं। ओके जी, स्ट्रेन गेज ऐसा बोलते हैं। तो यहाँ बहुत सारा इंपॉर्टेंट फार्मूलास है, मैं एक फार्मूलास लेना चाहता हूँ। फर्स्ट, स्ट्रेस का फार्मूला। So stress is defined as force per area. Units are Newton per meter square. Next, strain is defined as delta L by L, which is dimensionless, no units. According to Hooke's law, so what the Hooke's law will state, stress is proportional to strain. So अगर आपने एक proportionality रिमूव कर दिया, आपको एक velocity आएगा, elasticity, which is called Young's modulus. So Young's modulus is defined as stress by strain. स्ट्रेस का फार्मूला है F by A, स्ट्रेन का फार्मूला है डेल्टा L by L. So Young's modulus of elasticity, Young's modulus of steel is around 207 giganewton per meter square. 207 giganewton per meter square. Stress by stress. Stress is force per area. Strain is delta L by L. Okay. So these are basic things here before entering. Okay. Similarly, there is another one called Poisson's ratio. So Poisson's ratio. Okay, so if you see the Poisson's ratio, this Poisson's ratio is defined as mu. So this is defined as negative lateral strain by longitudinal strain, lateral strain by longitudinal strain. So उसका फार्मूला होगा माइनस डेल्टा डी बाई डी बाई डेल्टा एल बाई एल. Okay, that is the relation. Lateral strain is change in diameter to the diameter, longitudinal means change in length to the length. So this is the point. Now relation between gauge factor and Poisson's ratio क्या होगा? तो फर्स्ट ऑफ ऑल गेज फैक्टर लिखना पड़ेगा, गेज फैक्टर GF. इसका मतलब है गेज फैक्टर. हम गेज फैक्टर को कैसा लिखना है? इलेक्ट्रिकल स्ट्रेन टू मैकेनिकल स्ट्रेन, इलेक्ट्रिकल स्ट्रेन टू मैकेनिकल स्ट्रेन. इलेक्ट्रिकल स्ट्रेन का फार्मूला है डेल्टा R बाई आर, मैकेनिकल स्ट्रेन का फार्मूला है डेल्टा L बाई एल. Are you noting down? These are all important formulas. Please note down all these formulas, my dear. These are all important formulas. Revision is all about the formulas. Yes, Rohan. LR by R by del L by L, that is a gauge factor. And the relation between gauge factor and Poisson's ratio, there is another formula. So if you see gauge factor and Poisson's ratio. So gauge factor GF is defined as 1 plus 2 mu plus delta rho by delta L by L. This is for metals. No, this is for semiconductors. 1 plus 2 mu. This is for metals. This is for metals. Okay. And the gauge factor is equal to 1 plus 2 mu plus delta rho by delta L by L. This is for semiconductors. Is it clear? So gauge factor of semiconductors will be more because of this resistivity effect. For metals, the delta rho is equal to 0, but for semiconductors, delta rho is not equal to 0. So ultimately क्या होगा? Gauge factor of semiconductors is very much greater than gauge factor of metals. This phenomenon is called as piezoresistive effect. What we call it as piezoresistive effect. Clear? Next, I'm continuing the formulas. Next point we are going to take it as strain gauge and bridge. Bridges and strain gauge. Okay, so if you see the basic diagram, this is a cantilever beam. One end is fixed and the other end is free. Our strain gauge. And this strain gauge is a part of Wheatstone bridge. So this is our bridge diagram, plus minus the supply voltage. So this is our R, the current gets split into two parts. This is the I1 and I2. The current comes like this, and if I'm taking the galvanometer here, so this is infinity meter resistance. Can anybody tell me what is the bridge formula here? So when I apply the stress from this particular end, then this particular body is going to bend like this. When it bends like this, so there is a stretching movement here. So because of that, L plus delta L will happen. Here is the force you are applying. So first in the cantilever beam there is a bending moment, L plus small delta L, and because of that capital L plus delta L, and because of that here R plus delta R is going to come. Can anybody tell me? Thank you Ruchika. Can anybody tell me what is the formula? I am going to discuss mostly important formulas here. थोड़ा प्रेजेंट से आराम से रिवाइज कर लो. मोस्टली फार्मूला बेस्ड क्वेश्चंस आने के चांसेस ज़्यादा है. Can anybody tell me what is the formula? A Wheatstone bridge in which all the resistors are equal and एक resistor है strain gauge. वो strain gauge का resistance change हो रहा है because of the stress. The more stress you apply, the more elongation creates the more delta R. Can anybody tell me what is the expression for it? So the quarter bridge formula, I can take it as Vs by 4 into delta R by R. So this is the quarter bridge formula. Please make a note of these points. क्वार्टर याद होना है आपको, जितने लोग लाइव में हैं उसको क्वार्टर याद होना है. क्वार्टर याद हो तो अच्छा होगा. नोट कर दो बेटा, ये फार्मूलास पूरा नोट कर दो. यस, नोट कर दिया? चलो, तो ये क्वार्टर ब्रिज का फॉर्मूला है Vs/4 इंटू डेल्टा आर बाई आर। ओके, सो यहां से आप ये निकाल सकते हैं डायरेक्टली। दैट मीन्स इफ यू टेक दिस Vs/4, सो डेल्टा आर बाई आर क्या है, ये गेज फैक्टर का फॉर्मूला से आप निकाल सकते हैं। गेज फैक्टर का फॉर्मूला क्या है, डेल्टा आर बाई आर बाई डेल्टा एल बाई एल। सो डेल्टा आर बाई आर कैन बी रिटन एज गेज फैक्टर इंटू डेल्टा एल बाई एल। सो दिस कैन बी रिटन एज गेज फैक्टर इंटू डेल्टा एल बाई एल। ओके, तो ये होगा हमारा क्वार्टर ब्रिज का एक्सप्रेशन बनेगा। ओके, चलो उसके बाद और कुछ फार्मूलास लिखेंगे, लिखते जाएंगे ऐसा। सो क्वार्टर ब्रिज, हाफ ब्रिज, फुल ब्रिज। सो क्वार्टर ब्रिज का फॉर्मूला है Vs/4 इंटू डेल्टा आर बाई आर। हाफ ब्रिज का फॉर्मूला है Vs/2 इंटू डेल्टा आर बाई आर। फुल ब्रिज का फॉर्मूला है Vs इंटू डेल्टा आर बाई आर। So if you see now, as a full bridge, sensitivity of the full bridge is greater than the sensitivity of the half bridge, which is greater than sensitivity of the quarter bridge. Got it, my dear? Note of these points. As the number of strain gauges is increasing, note, as the number of strain gauges is increasing, as the number of strain gauges increasing, sensitivity of the bridge also increases. लिख दिया? चलो नेक्स्ट, और एक टॉपिक इसमें है पॉइजन्स ब्रिज। पॉइजन्स ब्रिज, पॉइजन्स हाफ ब्रिज, इसका फॉर्मूला है Vs/4 into delta r by r into 1 plus mu. Next, Poisson's full bridge, Poisson's full bridge का फॉर्मूला है Vs/2 into delta r by r to 1 plus mu. Please note down. Poisson's bridge बोलो तो क्या है ना, one strain gauge is attached like this and another strain gauge is attached like this. If this is a scenario, एक strain gauge experiences strain along the x-axis, one strain gauge will be experiencing the strain along the y-axis. Both the strain gauges are perpendicular to each other. This is what we call as Poisson's configuration. Poisson's configuration is more sensitive and better output also. It can experience both longitudinal and lateral. I think Ruchika, you are my old student. Somewhere in the old batches I have come across you. I think you are my very old student. I hope you are working as somewhere lecturer. Very nice to see you. 15 members are watching from the last 40 minutes. Very rare instrumentation students to get into the picture. Okay, so this is all about the strain gauge chapter. वन ऑफ द इम्पॉर्टेंट टॉपिक है, इसके ऊपर क्वेश्चंस आने के चांसेस बहुत सारा है. ओके, सो एक बार रिवाइज करो क्या क्या डिस्कस किया मैंने पहले से. इतना अच्छा कंटेंट दे रहा हूँ मैंने. रेसिस्टिव सेंसर्स में बहुत सारा इंपॉर्टेंट टॉपिक है, दैट इज स्ट्रेन गेज. स्ट्रेन गेज का बेसिक्स फॉर्मूला देखो. स्ट्रेस बोलो तो क्या है, स्ट्रेन बोलो तो क्या है, यंग्स मॉडुलस बोलो तो क्या है. नेक्स्ट, व्हाट इज पॉइजन्स रेशियो. ठीक है, आर यू वर्किंग समवेयर. नेक्स्ट, गेज फैक्टर का फॉर्मूला क्या है. नेक्स्ट, रिलेशन बिटवीन गेज फैक्टर एंड पॉइजन्स रेशियो. रिलेशन बिटवीन गेज फैक्टर एंड पॉइजन्स रेशियो फॉर मेटल्स कैसा होता है, फॉर सेमीकंडक्टर्स कैसा होता है. ओके, नेक्स्ट, ब्रिड्जेस एंड स्ट्रेन गेजेस में ऊपर क्वार्टर ब्रिड्ज का एक्सप्रेशन क्या है. ओके, क्वार्टर ब्रिड्ज का एक्सप्रेशन, इसके ऊपर बहुत सारा क्वेश्चंस, न्यूमेरिकल क्वेश्चंस आने की चांसेस ज़्यादा है. नेक्स्ट, क्वार्टर ब्रिड्ज हाफ ब्रिड्ज पी अंतर क्या है, क्वार्टर ब्रिड्ज का फार्मूला, हाफ ब्रिड्ज का फार्मूला, फुल ब्रिड्ज का फार्मूला. ओके, सो एंड पॉइजन्स हाफ ब्रिड्ज का फार्मूला, पॉइजन्स फुल ब्रिड्ज का फार्मूला. पॉइजन्स का क्वार्टर ब्रिड्ज का चांस कुछ भी नहीं रहता, क्योंकि पॉइजन्स में केवल मिनिमम नंबर ऑफ स्ट्रिंग्स प्रेजेंट इज 2. Okay, so let us move for the next most important topic, that is the flow chapter. I am taking most important topics first. I am going for the flow chapter. Next topic is the flow chapter. Flow meters. Okay, all of you are there, my dear? All of you are there? Most important topics I am going to discuss. Flow chapter. Yes or no? In flow chapter, the most important thing is first you have to understand Bernoulli's energy equation. You have to understand Bernoulli's energy equation. So what is the Bernoulli's energy equation? That is Gz plus half V square plus V by rho is constant. Potential energy plus kinetic energy plus pressure energy remains constant. potential energy plus kinetic energy plus pressure energy remains constant at any 2 points in a closed channel. I mean, at any 2 points, if you take 𝐺𝐳1 plus half V1 square plus V1 by rho is equal to 𝐺𝐳2 plus half V2 square plus V2 by rho. So, is it clear? That means if you take a pipe which is non-uniform shape, and if you take the flow axis like this, and with respect to horizontal line, if you take these 2 points, this is a point number 1, and let us take this a point number 2, and liquid particles are moving from each and every place. So this is Z1, this is Z2, okay. So this is a Bernoulli's pipe. So here the area is small, so the number of particles occupied here will be less. If you take this cross-sectional area, the number of particles occupied here will be less. But if you take this cross-sectional area, here the number of particles occupied will be more. The number of particles occupied will be more. So the area here is less, and the number of particles occupied here is less, their mass is less, hence the velocity is more. The head, water head, this head H1 is also less, then the pressure is also less. But whereas coming to this point, at the point 2, this head is H2. So here area 2 is more. Are you following, my dear? Here area is more, the number of particles will be more, the mass will be more, the velocity will be less, the head is more, so pressure also will be more. Have you noted, my dear? रुचिका तुकराल, रोहन मरकंडा, प्रयुषबुद्ध पोद्दार, सुमुखा प्रधान, कैसा नाम है रे ये पुरातन हर्ष साम्राज्य का और चोल साम्राज्य का राज्य में जो मंत्री रहता है, जो किंगडम में आस्थान विकट कवि रहता है ना, in that format your names are there. प्रकाश्या पोद्दार, सुमुखा प्रधान, रोहन मार्कंडा, रुचिका तुकराल. Very nice names. Likes बना दो. 13 people are watching. कोई comments नहीं डाल रहे. So this is the Bernoulli's energy equation. So there is a law of continuity here. There is a law of continuity. So what is the law of continuity? According to LOC, law of continuity, A1 V1 is equal to A2 V2. This is the formula. A1 V1 is equal to A2 V2. Have you noted? अरे यार रिप्लाई तो दीजिए, जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए, रिप्लाई दीजिए बेटा. चलो now let us move for मैकेनिकल फ्लो मीटर्स में फर्स्ट आएगा वेंचुरी मीटर. We'll take the first one, that is the Venturi meter. So if you see the diagram of Venturi meter, this is the inlet, and this is the converging diverging parts. Input, outlet. So this is the line of center flow axis, and if I am taking from the bottom view, it is a point which I can take it as Z1 is our Z2. So now you see here point number 1, and if you see this point number 2, so here this head is H1, this head is H2. जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा, आप सब लोग उधर है नहीं. So at this particular point, area is bigger, number of particles occupied will be bigger. When number of particles occupied is bigger, m1 will be more. If mass is more, velocity will be less. Head is more, pressure will be more. Next, here area is less, number of particles is less, mass is less, velocity is higher, head is less, so pressure is less. This is how the velocity v1 changes to v2 here. v1 to v2, there is a sudden rise in the velocity. There is a sudden rise in the velocity. Is it clear? I hope all of you are noting down. So if you see the expression for the Q, Q will be equal to CDM A2 square root of two delta P by rho plus 2G Z1 minus Z2. So this is the expression, Z1 minus Z2. Okay, so CD is called coefficient of discharge. The CD is called M is called velocity approach factor. Which is A1 by square root of A1 square minus A2 square, where A1 is the area of inlet, A2 is the area of the throat. Delta P is the pressure difference. Rho is the density of the process fluid. Okay, and Z1 and Z2 is equal to 0. So this is the basic common expression for the all the flow meters. You want to know the important. Understood? Next, when it goes to the orifice, this is the orifice. Circular, and this is the flow rate. So if you see this orifice, there is a liquid flow rate is happening like this. So this zone I can take as inlet. Now liquid enters here like this. This zone is got 2, but once the liquid comes out, it comes like this. Liquid comes like this and slowly it distracts. Okay, so now this particular zone is called vena contracta zone, zone 2. Okay, so let me take off these pictures. So this is the zone 1. This is the zone 2. Area at the zone 1 is bigger than the area at the zone 2, and the area at the zone 3 is least. Velocity at the zone 1 is smaller, velocity at the zone 2 is very higher, velocity at the zone 3 is still higher. So this particular zone 3 is called, vena contracta. What we call? We call this as vena contracta. जितने लोग लाइव में हैं मुझे एक बार थम्स अप दिखाइए बेटा. Very good. Naughty. And the expression is same. Vena contracta, orifice and venturi, CDMA, the technology. Yes, Rohan, yeah. Thank you. Visible. Chalo. One of the key features of the RFIs, it occupies less area and it gives a better flow rate. And both Venturi and RFIs both are obstructive flow meters, and the expense, size consumption, everything is less. Okay, next, when it goes to the 𝐂𝐚𝐴, if you see the 𝐂𝐚𝐴 is just intermediate to both. 𝐂𝐚𝐴 is intermediate. See, my dear students of instrumentation, I want to tell you this session is actually not at a plan. We are teaching only for actually EE and EC at this moment of time. But many of the students have pinged me or messaged me in the instrumentation group, sir, we need instrumentation session. So I requested the management in this business tightly scheduled the last week of January, which is very tight for any organization of gate oriented institutes. And I have taken a chance of 2 classes or 3 classes for taking for instrumentation students. Okay, try to utilize these long sessions. So if you go for the 𝐂𝐚𝐴 is just like an intermediate thing. It is not completely like Venturi. So this is a structure of the 𝐂𝐚𝐴. So this is a structure of the 𝐂𝐚𝐴, and the liquid flow rate goes like this. Okay, so it is a jet flow. It goes out like a jet flow like this. So Q is again the same formula, CDMA2 square root of 2 delta P by rho plus 2G Z1 minus Z2. Okay, so this is the 𝐂𝐚𝐴. So if you see the CD value, coefficient of discharge is 0.97 for Venturi. Coefficient of discharge is 0.65 for RFIs. Coefficient of discharge is 0.78 for 𝐂𝐚𝐴. Please make a note of these points. Clear? Yes. Chal. Let us go for the next. Rotameter. If you take the rotameter is a V-shaped tube. Rotameter is a V-shaped tube like this, and for which there is a float, like this. So if we check this, the float, so this is a flow. Happening like this. So this is a float. The area of the float is this AF. As the flow rate is increasing, this float moves up. As the float is moving up, the side area also increases. This side area also increases. So this is a side space. So as the flow rate increases, the position also increases. Its position also increases like this. Understood? So the more is the flow rate, the more is the height. So the Q1 by Q2 can be taken as H1 by H2. Yes, Rohan, it is a variable area flow meter. And the other important relationship here is the expression. So the weight force is balanced by that means the particular float, wherever it is in the water, there is a force in the upward direction and there is a force in the downward direction. So the force in the upward direction is due to the pressure and force in the downward direction is due to the weight. So what we can write, at steady state, the force in the upward and the force in the downward both must be steady. Force in the upward is the drag force, which is due to the pressure acting on the float, on the area of the float, where PB is a bottom pressure and PA is a above pressure. So this is a bottom and this is the pressure acting on the top. Okay, so this is a drag force. Whereas the force acting the downward is due to its weight minus buoyancy weight, net weight minus buoyancy weight. Net weight is mass of the float into gravity. This is a mass of the buoyancy into gravity. Mass of the float means density of the float into volume of the float, whereas this is density of the float, density of the water acting on the volume of the float into G, where rho is the density of the water. So this is rho F minus rho into Vf into G. So this is a force acting in the downward direction. So now equation 1 and equation 2 both will be equal. This 1 is 2. So if you state that balance equation, PB minus PA into area of the float is equal to density of the float minus density of the water into volume of the float into, so ये है हमारा basic expression. So this is a balance equation. So from this we can get the delta P. The delta P is equal to density of the float minus density of the water into Vf into G, the whole divided by area of the float, which is constant. Delta P is constant. That's why rotameter is taken as constant head variable area flow meter. Whereas the Venturi orifice nozzle, if you check, these all are areas are fixed. Once in that area is not changing because of the flow rate. So these are our Venturi orifice nozzle. Venturi orifice nozzle, these all are constant area variable head flow meters. You should understand this concept. Constant area variable head flow meters. All of you clear, my dear? To understand conceptually, these classes are suitable for the interviews also. जितने लोग interview जा रहे हैं वो लोगों के लिए interview में भी useful है. So majorly these are the things. Next comes the pitot tube. One of the interesting thing, the pitot tube. If you take the pipe surface and pipe center, so this is the surface, this is the center. Understood? Can anybody tell me which tube fills faster and what is the reason? Which tube fills faster and what is the reason? Tell me. Second tube fills faster because velocity of the fluid is more in center. It is not due to the velocity at the center, it is due to the stagnation velocity. Here the velocity is smaller. So that's why the content filled here is less. Here velocity is very much faster. The reason for filling is not the higher velocity, Markan. It is Rohan, it is not the higher velocity. The velocity is highest, I agree. This V1 is equal to less, but not 0. Here V2 is more, but here the V2 becomes 0, na? How can you say it fills because of higher velocity? No. Whenever it touches this obstacle, na, the velocity becomes 0. Kinetic energy becomes 0. Energy neither can be created nor can be destroyed. It has to convert from one place to another place. Am I right? Audible hai? आवाज आ रहा है नहीं? जल्दी बताओ भैया. Yes. It is not due to the velocity, higher velocity. It is due to the. It is not due to the higher velocity. It is due to the velocity becoming 0 converted to pressure energy. 𝐂𝐚𝐭𝐜𝐡. Velocity 0, but the velocity kinetic energy is converted to pressure energy. So now if you take any point here the pressure acting is P1. If you take any point here the pressure acting is P2. Okay, so this height I can take it as H1, this height I can take it as H2. Okay, so if you simplify this, if you apply the Bernoulli's law for this, suppose if you have taken from the bottom, so this height I can take it as Z1, this height I can take it as Z2. So GZ1 plus half V1 square plus P1 by rho is equal to GZ2 plus half V2 square plus by rho. So here if you see, the V1 is not equal to 0, but V2 is equal to 0. Z1, Z2 gets cancelled, and the P1 is smaller or higher? This is smaller. P2 is higher. So half V1 square is equal to P2 minus P1 by rho. Interesting. अप टू नाउ जो कुछ वेंचुरी आरएफएस आज डिस्कस किया है उसमें डेल्टा पी बोलो तो P1 माइनस P2 है, लेकिन यहाँ डेल्टा पी बोलो तो P2 माइनस P1 है. So V1 is equal to 2 into delta P by rho. So square root of 2 delta P by square root of 2 delta P by rho. So this V1 is called approaching velocity. Approaching velocity, the delta P is equal to P2 minus P1. P2 is called stagnation. P1 is called static. And the delta P is called dynamic. Stagnation is also called total pressure. Okay, my dear. So these are the mechanical flow meters. Now let us move for the electrical flow meters list. Ultrasonic flow meter. So in short we call it as ultrasonic flow. So how this ultrasonic flow meter will work? So if you check the ultrasonic flow meters, The combination of piezoelectric crystals. So one crystal is kept at the top here, another crystal is here, this is one crystal Tx, this is the Rx, and this is the flow axis. Okay, and this is our inclination. So this is the theta. So this is a flow vector, this is the ultrasonic vector. Okay, so the time shift ultrasonic flow meter में the delta T is given as 2D VF cos theta by S square. Jaya, where are you from? Where D is the distance between the crystals, the diagonal distance. VF is the flow rate. Okay, so let me write all these things. VF is the flow rate. Vs is the sonic velocity. D is the diagonal distance. Diagonal distance between the crystals. Next, that's it. Next, let us go for the another one, Doppler shift. The Doppler shift delta F is given as 2VF cos theta by T. Very good. Noted. Next comes the electromagnetic flow meter, EMFM. Electromagnetic flow meter. If you see the electromagnetic flow meter, this is the pipe. So this is the North Pole. The South Pole. These are the magnetic flux lines. So this is the flow, conductive flow, fluid coming from this. The conductive fluid coming from this. So now it is going to touch like this. So now here we are going to get some electrodes. So these electrodes will give you the output potential. Can anybody tell me what is the 𝐸0 for electromagnetic flow meter? When a conductive fluid is traveling through a pipeline under the magnetic field perpendicularly, exactly at the center, the fluid particles are moving like this. Then suddenly there is a magnetic field. Because of the magnetic field, there is a shift in the motion, which creates the charged particles to distribute not equally, unequally, so the left and right. So when you connect the electrodes are going to give certain potential. So this electrodes potential is given as what? This 𝐸0 is proportional to flow rate. This 𝐸0 is proportional to the magnetic flux density. So this 𝐸0 is proportional to B into Vf. And if we move this is the P into D into Vf. So P is can be written as Q by A also. Q by A, where A is the pi d square by 4. So it will be 4 QB by pi d. So this is the 𝐸0, 4 QB by. Clear? Chalo. That's it. Let us move for the next. Homework I am giving. You please revise the RTD, thermistor and thermocouple. So these are the major areas. RTD का formula RT is equal to R0 into 1 plus alpha delta T. Thermistor RT is equal to R0 into exponential beta 1 by T minus 1 by T0. Thermocouple EMF of the thermocouple is equal to sensitivity into TH minus TC. So these are the major formulas. Okay, so please exercise. Q is a volumetric flow rate. V is the average flow rate, meter per second. Q is the volumetric flow rate, meter cube per second. Okay, समझ गया आपको? So Q is equal to area into velocity. अरे आप इंस्ट्रूमेंटेशन बच्चे हैं तो आपको पता होना है, Q बोले तो क्वांटिटी रेट है. Enough for today? Okay. चलो. So मेजर टॉपिक्स हमने डिस्कस किया है. मेजर टॉपिक्स हमने डिस्कस किया है. तो ये होमवर्क आपके लिए दे रहा हूं, आपने प्रैक्टिस करो आरटीडी, थर्मिस्टर, थर्मोकपल के ऊपर. अच्छा लगा सेशन? आर यू बेनिफिटेड? मेजर टॉपिक्स हमने डिस्कस किया. स्ट्रेन गेज, आरटीडी, enough for today. In the next classes we'll discuss, thank you, in the next classes we'll discuss optical instrumentation. Anybody is having any doubts, you can ask me here. Thank you, one and all. Anybody any doubts, you can ask me.